All right, we have one last definition. Really, the perpendicular ones come from lesson 1.5. It's called the perpendicular bisector. Perpendicular means you meet at right angles, and bisector means what? Two. So if I have a perpendicular bisector, it's a line, segment, or ray that is perpendicular and we're going to put this in here so you can see a little bit easier, to the segment at its midpoint. What does that do? It creates two, and that's hard to read, two congruent segments and four right angles. Let me draw you a diagram of this. Let's say I had a line segment right here, AB, and there's going to be my midpoint. A perpendicular bisector is going to be this line. Let's call this line, let's call it line N. Just do a lowercase line n here. I know that it's going to form this right angle, and I also know that it's going to give me two congruent segments. So we would say line N is the perpendicular bisector of segment AB. Now, this is going to be the stop for right now. We're going to go now and work on some of the problems on the very last page here of our example worksheets here, okay? And for some of this, it's just so we can understand how things are being formed. And I just want to make sure we're all on the same page. And the key with this is understanding the problem-solving process. So we're not going to do the first one. We've already worked with one like that before. But what we're going to do is talk about if we're working with coordinates. They said find the length of segment PD if the coordinate for P is a -7 and the coordinate for D is a -1. So please understand they're drawing a number line here. Here's 0. D would be at -1 and P would be over here at -7. Well, here's the work you'd have to show me for that. The absolute value of a -7 minus a -1 is going to end up being 6. That's all the work you have to show. So that gives me the length using the coordinates. So use that to play with a little bit. Now, here we have another problem. By the way, that's number 10. You can't see that. It got knocked off there by the copy machine. We want to make sure that we can solve for the length of line segments and you can communicate it clearly. So here, let's look at the problem. It says if the length of segment AX equals 45, find the value of each of the following. I want to know the variable Y. So first of all, what do I have? I have a length of a line segment and I have my diagram of the line segment. Pretty big. Then we also know I need to find the length of the two segments. So here for the first one, it's like, where do I want to go? I know where I want to go, but how am I going to do this? Well, first thing I'm going to do is I'm always going to mark up my diagrams. So from here to here, I know it's 45. So I think about it. Oh, I have postulates. I know in the back of my head I have this rule that tells me the two sums equal the whole. So I go sum of the parts equal the whole. So I go here, 2y plus 1 plus y minus 1 is equal to 45. So I get 3y is equal to 45. So I can do the sum of the parts equal the whole, right? Solving for it, divide both sides by 3 at y is equal to 15. So that's our first one. Now I need to find the length of segment AQ. What do we do with the length of segment AQ? Well, we can solve for it. So I can go 2 times 15 plus 1. Well, 2 times 15 is 30. 30 plus 1 is 31. So I know the length of my line segment is 31. And I'll have to do the same thing. Now, here's a cool thing. To find QX, could I possibly go 45 minus 31 and get 14? Would that still be valid? Yeah, because I already knew that this one was 31. Or could I plug it in, plug it in? Yeah, I could plug it in. I know, crazy, isn't it? So if that's the case, if I plugged it in, I'd end up having, make sure I got my variable here correctly, 15 minus 1 would be 14. I got the same answer either way. Notice how I got there was slightly different, but I still got there. So it's a huge thing that we're still be able to do. Well, I hope this will help us get started on working with line segments. Please remember the key. Know what your given information is, what do you have, know what you're solving for, where you want to go, and then think of all the new processes we just learned on how we're going to get there.